Hello, it's Carly McAvoy. I'm doing the test prep for test 3. This is the last portion of it from 17 through 21. 17 is going to ask you to find x for two similar figures. This is a pretty simple problem, and this is a very easy example of it. But what I know is if they're similar figures, that means there's a scale factor that takes one of these, takes this size up to that, and then it takes proportionally the long side up to this. So I can set up a proportion. 5 is to 12.5. That is, this short side is compared to that short side the way that 17 compares to this side. And then I'm just like any other proportion can cross multiply the means. I'm going to take 12.5 times 17, and that's 212.5. 212.5, that was so sloppy. And then cross multiply the extremes, and I get 5x. So 212.5 divided by 5. And I get 42.5. And that would be meters, just like the other one. So it's a very simple multiply your means, multiply your extremes, and then divide by your coefficient. You just have to make sure that you get the right sides corresponding. Okay. Next one is a Pythagorean theorem word problem. A 20-foot ladder is leaned against a house such that the base of the ladder is 4 feet away from the house. How high up the house is the top of the ladder? So you want to draw a picture. Any one of these things could be missing. We could be asking about the distance from the house, the length of the ladder, or how high up the house. This one, no matter which one they're asking for, this is like a ladder that's leaning against a house, and it's a certain distance away from the house, right? I might not have drawn this proportionally correct, but the ladder that's 20 foot long is this one, right? And it's the base of the ladder is 4 feet away from the house. That's that. And the question is, how high up the house is the top of the ladder? That's A. And what you know about right triangles is that A squared plus B squared equals C squared. A is, we don't know. B is 4 and C is 20. Subtract 4 squared from both sides. A squared equals 20 squared minus 4 squared. You can simplify those at any time. I'm going to take the square root of both sides, and I get A equals the square root of 20 squared minus 4 squared. And so I can just put that directly into my calculator. Any calculator can do this. I'm going to do a square root and just do 20 squared minus 4 squared. And that gives me 8 square root of 6. So what do you do if you get that and you want the decimal answer, right? So I don't want 8 square root of 6. I want the actual decimal. Let's see if I can do that with this button. I don't think so. Okay. So I'm going to go back and say second function, square root, 20 squared is 400 minus 16. I'm going to put a decimal point there. Yeah. So I'm going to enter my answer. I put a decimal point in there, and it gives me that instead of the simplified radical, it actually gives me the decimal equivalent, but I had to tell it that decimal. I wonder if I had done this, 20 squared minus 4 squared decimal. That, yeah, syntax error. They don't like that. That's why I thought I had to do that out. But if I could do, let's see, if I just did 16 decimal, yeah, it just doesn't like you to put a decimal after a square like that. I didn't think it would like it. But anyway, I didn't say what to round this to, but on the test I will say. So let's say that I ask you to round this to the hundredths. That's a good one, because what we get for A on the calculator is 19.59591794. Okay. What is that answer rounded to the hundredths? If I want an answer, it's approximated, so I give it the wavy line. I want it to be to the nearest hundredth. That means I want two places. Hundredths has two places. So if I go to the two places, and this is 5, that rounds that up. 59 then rounds up to 60. If you put 0.6, that's not to the hundredths. 0.60 is to the hundredths. So this would be the approximated answer for that problem. Okay. Y varies inversely with x, and y is 21 when x is 2/7. Find y when x is 15/4. So there's going to be some problem on the test where you have to deal with fractions, so deal with it. Inverse proportion, y equals k over x. What you do is you put in the y that they give you, and you put in the x that they give you. You want to get rid of 2/7, so you're going to multiply both sides by 2/7. 2 times 3 is 6. The 2/7 cancel, and that's k. That's what I find out first. And then I want to go back and find out what's y. Now I know k is 6, and I know x is 15/4. First of all, you're welcome to just do that on your calculator. Calculators have these great little fraction functions. It's okay with me if you want to do that. Here's what I have. I have 6. Can you see that? 6 and over another fraction, 15/4. Enter. And that's 8/5. So if you know how to use your calculator effectively, that would be awesome. If you don't, this is like 6/1 divided by 15/4, which is 6/1 times 4/15. And then I know, well, what can I cancel here? 3 goes into 6 twice, and it goes into 15 5 times. 2 times 4 is 8, and 1 times 5 is 5. Thus, we get 8/5 for our y, and the k, which wasn't our final answer, but we had to get along the way. We had to get that constant, that coefficient. The constant there was 6. Okay. And then what about if y varies directly with x? Well, then we use the formula y equals kx. We know that y is 195 when x is 6. You can write k first or second, whichever. If we divide by 6, what do we get? 195 over 6 is 65/2. I'm going to leave it as a fraction, even though I could make that, because 65/2 is exact as a decimal, right? 32.5, whichever one you want to use if it's exact. And then we want to know, what if x was 39? So we know that k is 65/2, and we know x is 39, and we want to multiply those together to find out what y would be, and that would be 1,267.5. You could also do it as 65/2 times 39. Same answer whether you use the decimal or the fraction answer for that. 1,267.5. That's your actual answer. The k you had to find along the way to get there. And finally, a proportion type of word problem. A ranger caught and tagged 150 deer one year. The next year, they caught 80 deer and found that 19 were tagged. Use this information to estimate the number of deer in the park. Well, they have to do things like this for fish or deer. If you have a big lake, you can't actually go out and count all the fish. So what they do is they tag them, and then they catch them, and they figure out the proportion that were caught, that were tagged, and use that proportion then to figure out approximately how many fish are in the lake. It's not exact, because maybe the idiot deer and fish are the ones that keep getting themselves caught and looked at, and the other ones are getting away. So who knows? But it is something. So what we have is tagged to total. I always like to write off to the side the two things that I'm comparing. So he, the first year, the ranger, or maybe a bunch of rangers, I don't know, they tagged 150 deer. They didn't know how many deer were in the park. That's why they were doing it. But they came back the next year and they found that 19 were tagged out of the 80 that they caught. And they can use this to estimate. So if we cross multiply, what is that, 1200, 150, no, 150, I was thinking that, way off. 12,000, 150 times 80. 12,000, the magnitude error there. And then divide both sides by 19, which is our coefficient there. So we have 12,000 divided by 19, which is 631.5789. And so what's your estimate for the number of deer in that particular little park? Well, we don't ever have half a deer. So we're going to say we estimate there to be about 632 deer in that park. So you can use your proportions to solve things like that. That would be an example of direct proportion, because the number of deer tagged goes up. I mean, when you it's proportional, right? So that's how they can figure that out. So it's like a direct proportion. Okay, if you are watching this and you're going to test on Monday, then you can come to my office as early as 10 a.m. I'm in building 34, room 140. If you show up there at 10 a.m., you can start the test early if you think you would like extra time. We'll also go back over there at noon for those people who have a free after class. You can have extra time before or after, and you have to have watched this video to get that message. Have a fantastic day.